Presto to switch Hive to Presto. But the problem with Presto back then, and still is kind of a problem with Presto now, is Presto does everything in memory. And so if you have an operation that can't fit in memory, Presto just fails. You can't use it. And so, and I worked in notifications at Facebook, so we couldn't use Presto, but I also didn't want to use Hive because Hive was slow and terrible. So like I was one of the very first early adopters of Spark at Facebook. I think I was like the third or fourth person to like create a Spark job at Facebook. And it was great. It was a slam dunk in so many different places in my usage, both at Facebook and further on in my career. I've tried all the different APIs for Spark, right? There's Spark SQL, there's DataFrame, Dataset, PySpark, Spark R. Like, I always joke with people about Spark R because people forget that you can actually write R code with Spark, and it's kind of crazy. But anyways, I attribute learning this technology as one of the main reasons why I was wildly successful in big tech, because I learned this framework very, very thoroughly, and I know all the ins and outs of it. And so it's been great. I've been using it since then, like since 2017 to 2023. So like so many years, like six years of just using Spark, and it's just gotten better and better and better since then. And yeah, let's keep going here. So why is Spark so good? There's a couple things. Spark is really good because it leverages RAM more efficiently and more effectively than previous iterations. So for example, like if you wanted to do a group by computation in Hive or MapReduce, everything had to be written to disk, and then written to disk and read from disk, and every single step had to be written and read from disk. And it made it very resilient. Like Hive and Java MapReduce jobs were very resilient, but they were also incredibly painfully slow. Spark was able to kind of short circuit some of that and minimize the amount of times that it needs to write to disk. Spark essentially only writes to disk when it has an operation that it doesn't have enough memory for, and then it will do this thing called spilling to disk. Generally speaking though, like you don't want Spark to spill to disk. You want Spark to use RAM as much as it possibly can, and that's going to be where you get very effective and fast computations with Spark. Spilling to disk makes Spark, it essentially has Spark go back to being Hive, and it's again being kind of slow. So another thing about Spark is it's storage agnostic. Like you can read whatever you want, right? Whether it be a relational database, a data lake, a file, MongoDB, whatever you want to read, Spark can read it easily. Also, Spark has a massive community. And you don't need to use Spark with Databricks. You can use Spark with whatever technology you want, and it works great. So that's pretty much what is going on with like why Spark is so good. When is Spark not so good? There's going to be, I think, two cases when I would say that you don't want to use Spark. The first one is similar. It's a very similar guidance to what I said about Flink. Was if you're the only one on your team that knows Spark, then like you probably shouldn't use Spark. You should, or you should teach your team so that you can have better maintenance and better reliability, and you can distribute responsibility more effectively. And also, your company might already use something else. Like a lot of companies bet heavily on BigQuery, or they bet heavily on Snowflake, or they bet heavily on another kind of technology that isn't Spark but also works. And in those cases, like it's better to have 20 BigQuery pipelines than it is to have 19 BigQuery pipelines and one Spark pipeline. Like it's just like homogeneity of pipelines matters a lot. I've used that word a couple times in some of these presentations, and that's when like you don't want to bring in Spark in those cases. You want to just use what the company's betting on. Okay, so how does Spark work? So I like to use the analogy of Spark as like a basketball team. So the basketball team has three things in it. It has the plan, which is the play that the basketball team runs. The driver is like the coach of the basketball team, and the executors are the players of the basketball team. So we're going to be kind of using more analogies here. I need to update these slides so they actually have like basketball players in them, but it'll make a lot more sense as we kind of go through this. So remember, we have the play, the coach, and the players. And those are going to be the three things that we have, but they're called the plan, the driver, and the executors. Okay, so the plan. You can think of this as the play. This is like the coach will... Okay, so three things that we have, but they're called the plan, the driver, and the executors. Okay, so the plan. You can think of this as the play. This is like the coach will tell the players what play to do. And this is going to happen like where the play can be described in whatever way you want to do it, whether usually it's going to be Python, Scala, or SQL, or R if you want to be a weirdo. And then the plan is evaluated lazily. What that means is the plan doesn't actually run until, I like to say, like a player takes a shot, which means like they either like try to write data out somewhere, or they try to collect data somewhere. So that's what taking a shot means, like writing output or collecting data. And the collect, what that means is like essentially they are taking information from the play and bringing it back to the coach to have the coach tell them what to do next. And that's going to be the main things around the plan of how Spark works. So this is going to be like your data frame code. This is going to be your Spark SQL. This is going to be your data set API code. And that's essentially what we're going to be working with here. So that is kind of the plan of how Spark works. Okay, so you have the driver, which is like the coach. You can think of like the coach reads the plan. So the coach like tries to figure out what plan to run and what